Hello, Year 9. This week, you've been thinking about adding three-digit numbers. 123 plus 321 gives us 444. The answer uses only one digit, in this case 4. There are plenty of other examples which come to mind pretty quickly, slightly sort of cheating ones like 111 plus 111 gives us 222, and other slightly more interesting ones. So the question is, how many are there? How many three-digit numbers have this property that when you write them backwards, add them together, you get a single-digit answer, in the sense of it uses only a single digit. And then what about with four-digit numbers? How many possibilities are there for four-digit numbers? There's two there. Are there more? Yes. So let's think about writing this out as a column addition. What we'd see straight away is that we'd have B10s and B10s that make two B10s, or I suppose 20B. And so that tells us our answers are going to look like that. The answers are going to have to be have an even number in the tens. So 2, 2, 2, 4, 4, 4, 6, 6, 6, or 8, 8, 8. So in which case then, if I have, say, B being 110, and then I go 110, 110, that makes two tens, and then the C and A ones must make a 2, and the A and C hundreds must make a 2. So altogether I need to have A and C adding up to 2. For the next option, 444, I must have B and B being two tens, and two tens makes four tens, and then C and A ones makes four ones, and A and C hundreds makes four hundreds. And similarly for 666 and 888. So then what are the possibilities I can get from this? Well, if A and C makes 2, then it's either 1 and 1 for A and C, or it's 2 and 0 for A and C. Now you might slightly object to that, because 210 from backwards is 0, 12, which is not a three-digit number. I think it's fine, but ignore it if you want to. And then we should work out all the other possibilities in the same sort of way. So if I want, say, A and C to be 4, I can have 3 and 1, or 2 and 2, or I would say 4 and 0. Though I agree 0 and the 4 might not count properly because it's not a three-digit number. And that's basically it. So kind of job done, all finished, except it's not, because we've missed at least one. 605 plus 506 gives me 1111, and so too will 704 plus 407, 803 plus 308, and 902 plus 209, because they all make 11, which gives us 1 1 and 1 10, and then we have no 10s, but we do have the extra 1 10s, and that's why I get another 1 there for the 1 10, and then the 600s and 500s make 11 hundreds. So there are those possibilities adding up to 1111, which again uses only a single digit, a repeated digit. Are there any others? Are there any other ways of getting that? Well, we could try it with 5s, like 952 and 259, because the 9 and 2 would give me 11, and then the 5 10s and the 5 10s would be 10 10s, and then the 1 10 from the 11 would give me 11 10s, which would be a 1 in the tens and an extra 100. And that's why it won't work. Because if C and A make 11, then A and C make 11, but the extra 1 will make it 1211. So there's a possibility of it being 1111 with a 5 as the tens digit, but actually that doesn't work out. What about that? Coming at 2222, no, by a kind of size argument. Even if we start with 9,909 and write it backwards, 9,999, we don't get 2,222. Our answer is less than 2,000. And so we're done with those options using three-digit numbers. What about four-digit numbers? Well, here it feels a bit different because the way the numbers are paired up, then A and D, the way the digits pair up, A and D have to make a value, and B and C have to make the same value, but they're independent of each other. So if I want to make 1111, I've got to think about different ways of making A and D add up to 1, which is quite easy, 1 and 0, and then B and C add up to 1, which is 1 and 0. But of course, they can be in different way around. It can be 0, 1, or 1, 0. What about if we want to add it to 2? Well, same thing. So A and D, the first and last being 2 means 2 something something 0 or 1 something something 1. And then the middle part, the middle pair adding up to 2 means that for each of these exteriors, 2, 0, 2, 0, 2, 0, there are different interiors, 2, 0, 0, 2, and 1, 1. And then similarly, we can have 1, 1, 1, 1, and 1, 1 on the exterior. And on the interior, we have 2, 0, 0, 2, and 1, 1. Thinking of these two as inside the sum, the interior of the sum. And then for 3, we have those options. So again, we have the two outer digits, the exterior digits making 3, and then the interior digits need to make 3, but in different orders, 3, 0, 0, 3, 2, 1, 1, 2. For 4, we'll throw in more possibilities, and so on. And so we can go from here, and we can find them all, and we can count how many there are altogether. Can I get a 5-digit answer? Can I get 11,111 with a similar argument to what we saw before? I'll leave you to think about that. I'll leave you to see how that works. So to summarise then, we have reasoning with 3-digit numbers, in which case we found out the value of b, and we found that the tens, the value in the tens column would be 2b, and therefore that forced b to take options 1, 2, 3, or 4. So as we got 20, 40, 60, or 80 in the tens. And with 5-digit numbers, will that be the same, or will it look like more like the 4-digit numbers where we had those sort of independent blocks? We had the first and the last and the middle two, and they could function independently of each other as long as overall they got the single-digit answer. So what will 5 digits look like, do you think? And the last thing just to throw into the mix is actually we could do this all by algebra. Because when we write ABC, we mean 100A and 10B and C. 932 is 930, 3 tens and 2 ones. So we mean 100A plus 10B plus C. So when we write it backwards and add them, we get 100A plus 10B plus C plus 100C plus 10B plus A. So I get 101A, 101C, and 20B. And so all the possibilities go from 101 plus 20b, where A and C makes 1, up to 1,818 from A and C both being 9, 9 and 9 making 18. And then we've still always got the 20b. And so we can substitute values for b into there, or we can predict which values of b we can substitute into there, so that what we end up with is an answer using a repeated digit only. So this one here, I'm going to make b equal to 1, because I'm going to get 202 plus 20, which is 222. For the next one, 404 plus 20b, I'm going to make b 2, so I'm going to get 404 plus 40, which is 444, and so on. So perhaps try and do the problem using an algebraic approach by writing out all the different combinations symbolically, and then identifying which values satisfy those symbolic relationships. Bye for now.